One, two, two.
Check 1 2 3 4 5
Hi everyone, we'll be starting soon.
Okay, good morning everyone. Let's have a seat. So time management is a great challenge, right? So let's be seated and let's get started, okay? Okay, so welcome to everyone in this technical session number 10. So the basic objective of this session is to explore what are the nature-based solutions and how do we implement these nature-based solutions for the, water security. I have seen that there are 5 distinguished speakers in this session, and geographically they are from Turkey, India, Nepal, Thailand, and Egypt. So just a few housekeeping rules. I think Kausal is also explaining that, right? So we have 5 presentation. So each presentation have 10 minutes for presentation, but because it's a very challenging to keep the time, so I would like to request all the participants to keep your questions once the all the presenters they have completed their presentation. So I will open the question and answer session at the end. So I hope that's fine to you. Okay, so my colleague Dr. Locke is also here. So we are working in the same program called Water Engineering and Management Program of AIT. So with this brief introduction of this session, I would like to call upon the first presenter, Dr. Mohammad Moirul Hassan, to present. Thank you.
Welcome to my presentation. I am Dr. M.D. Moinullah Hassan,
I'm an assistant professor at the Department of Real Estate Development and Management in Ankara University. So, firstly, I acknowledge that DED and Swindon Exceed, they give us fund to come here. So, I'm happy for that. And my topic is about mainstreaming nature-based solutions to transform into a water-sensitive city, a study of Ankara. So we all know about water. So water, it can pose a catalyst for city integration through circular economy principles and place-based transformation. So making a water-sensitive city like Ankara or other cities, so through nature-based solutions can be described on that is livable, resilient, sustainable, and productive by use various tools. So in terms of discussing about the nature-based solutions, where many tools are using, and in terms of also water, so like biological pond, like wetlands, vegetated soils, rainwater harvesting that are also common, green roofs, permeable pavements, infiltration walls, cleansing biotopes, and so on. So practices of these type of tools can enhance existing ecosystem, protect local ecosystem, save water, mitigate flood, waterlogging risks, and use of local plants and many other things. So these all are to combat climate change and also adapt to climate and many other things. So now, if you have a look in Ankara, is a capital city in Turkey, and located at the central Anatolian region in Turkey, poses a cold, semi-arid climate, middle latitude steppe climate, cold and snowy winters, and hot and dry summers. So the population has increased a lot. In 1927, just I mentioned here two figure, it was in 404,000 plus in Ankara, and now is 5.76 million people. So last year, 84,000 people has increased. The population growth rate is increasing. So population is increasing, but the water supply, if you have a look, it has a serious problem. So rapid urbanization, sprawl-based urban development, substantial decrease of natural vegetation like water bodies and agriculture are reducing, but substantial increase of built environment, real estates and so on, all are proportionately affect individuals to access safe and adequate water in settlements and neighborhoods in Ankara. So around 98.5% of Ankara's water supply is dependent on surface water sources, and in 2014, for example, per capita water consumption was 2011 liter per day, and now it has increased to 250 liter per day in 2021. So in my study, I have used the mixed method research, especially secondary data collected by government data institutions, as well as I have also focused about activity report that has done by municipalities and Ankara Metropolitan Municipality. So in Ankara, there are 25 municipalities, and on Metropolitan Municipality, in total is 26. So my focus is about that. So I have studied all the activity report. All the reports are more than 200 plus pages. And also in this study, I have done 25 key informant interviews and selected from knowledge producer, 4 from knowledge producers, those who are academic or landscape architect or urban planner and environmental engineer. And also the knowledge filter like journalists who are involved in environment, local politician also, and mayor. And another is the knowledge actor, around 14 from government and also municipalities and also NGOs, and for 4. In total is 25. Tried to those who are involved in this project or those who are works in environment protection department in municipalities. So firstly, I have to find that what existing NBS practices are available in Ankara, especially in water. So there is a national project which is called Millet Bahçesi project. So it's about the National Gardens project. So it is implementing by Ministry of Environment, Water and Climate and Urbanization and Climate Change. Another is the municipalities. They have also implementing some projects like climate resilient sustainable parks projects, rainwater harvesting. These are done by Ankara Metropolitan Municipality, and Ankara Metropolitan Municipality, they have the rainwater harvesting tank in parks. Around 40 parks, they are now they are implementing in rainwater harvesting tanks. And Golbashi Municipality, another municipality, it is also the rainwater harvesting, grey water poverty project starting in 2020. And all the municipalities, they have very limited scale, like pervious pavements, grassed soils, constructed wetlands, water squares, rain gardens, tree planting, and tree planting is very common. And some nature-based solution projects are implementing by NGOs, local NGOs. Already some projects already completed, like Nature at My Door project, nature-based metropolitan studies, Imrahor Valley, and Chidem Neighbor Bustani and nature-based solution for renaturing cities 2016 to 2020. The last project by Ecodenge, it is European funded project, and this project already completed, but some of the best practices also you can find from this project. So this I have collected from surveyors, respondents. So what practices are done by the municipalities in Ankara? So we found that the many biological pond also implemented, also tree planting is, this tree is common, and also some constructed wetlands. Around 60% respondents, those who are key informants, those, and I forgot to mention you that the informants, they are at the top level, mainly officials or project leader or something like that. We have, in our department, we have collaboration, protocol with municipalities. That's why it was very easy for me to collect data from there. So around 60% respondents informed that the main motivators behind these practices, as the authority or municipality is considering NBS as an important tool. So when we are discussing, when I have focused the questionnaire that like very important, less important, something like that, and 60% they told that it is important, and only 10% is very important, but remaining they are not much more important, something like that. Informants state that the grassed soils, tree planting, and rainwater harvesting should be the three best water sensitive applications for Ankara that are now concentrating by the municipalities. These are 6 parks pictured here, and some like Smith Inuni Park, which is this park. It is awarded one of the project, and also very good implementation by Chankaya municipality in Ankara. So these are 6 parks. It was when it was a project like Ecodenge, and it was only 2 parks. Now there are 6 parks because mayor, he's he has some intention to the sensitive, water sensitive city and her perspective. Another, this one is implementing by rainwater harvesting in Goksubar, just an example. City mayor, Ankara Metropolitan Municipality mayor, and he's implementing this type of rainwater harvesting tank in parks. 40 parks will be implemented. Now only few parks they are already implemented. Another, this is a rainwater harvesting tank in Golbashi. Also the Golbashi mayor, he was very water sensitive, I can say. Also it is close to his office. So some regulations I have also mentioned here, what regulations action is available. So I have found that urban design guidelines in 2015, they have also a regulation on rainwater harvesting, collection, storage, and discharge system in 2017 is old, little bit. Ankara province local climate change action plan, Ankara metropolitan strategic plan now implementing 2020-24. Ankara province drinking water, wastewater, and stormwater management master plan in 2020, and Ankara green city action plan. This is new, and they are now preparing this plan. So it's very important, hopefully, in future. And when we are discussing about the hot knowledge design and political will, the parks within the borders of Chankaya municipality are built by following procedures for designing and activating green areas in mayor's political will. Golbashi municipality also follows some local design and principles with mayor's political will, and Ankara metropolitan municipality follows local design all. As per local experts and designers, existing implementations are compatible with local community design, but 27.3% they stated that existing design is not compatible with local community design. So when asking about the barriers to implement NBS practices, and so we already found that from NGOs, from metropolitan municipalities, NGOs, they informed that the lack of finance also one of the 27%, lack of knowledge and expertise is one of the major focus here, the barriers of implementing NGOs. But in terms of municipalities, there were 26 municipalities, they informed that the lack of knowledge on risk, cost and investment cost, higher investment cost is the main reason, the barriers to incorporate NBS practices. So another social acceptance, lack of acceptance also they are very important. So the European funded project that was did by Ecodenge, and also they focused about the social acceptance also very less in Ankara. Mainstream nature-based solutions, so when I asked the questions like, so they are focused about the knowledge on risk, cost and know-how is 15%, something like that, and social participation 15% and investment 9%. So when I did the what focused activities done by NGOs as well as municipalities, because municipalities did some projects, and they said the roundtable discussion involved with the policymakers and stakeholders, and also documentation and publication of water-based practices. But they have not much focused about the exchange visit with the municipalities and relevant stakeholders. Also information share, processing and sharing through web and digital media. So if you have a look in website, all 26 municipalities, not much more there. I couldn't find, even my students also worked in this, we didn't find. And the local NGOs also, they are much more active and launched a workshop, documented and collaborate with mass media and so on, but they have no much more visit with the municipalities. So process of sharing knowledge and sensitizing policymakers, we found that the collaboration with local stakeholders, especially neighborhood levels, would be the best option, as well as area-specific policy, if around 33%. So through this way, we can share the knowledge and as well as sensitize the policymakers. So ways of mainstreaming NBS in Ankara city, we also found that the existing plans, policies, and strategies relevancy with water-sensitive cities only 21%, and impact of ensuring scaling up the learning and best practices 21%, and share the result of experiences learning with policymakers and other implementing important stakeholders. It's around 20%, something like that. So these are the way how we can sensitize the policymakers. Now conclusion, it has identified that only 4 mayors out of 26, but I have found that some municipalities, they have the motion or vision, also their goals about the nature, but they are not implementing. But these 4 municipalities, they are implementing, are doing some NBS practices to ensure cities' water supply, following water-sensitive principles, strong and committed political leadership like Golbashi and Chankaya, and good coordination among relevant agencies seem indispensable for making water-sensitive city. Sensitization of NBS to both municipal authorities as well as public awareness together could better work for sustainable NBS practices in Ankara. Existing government legislations are not enough to ensure NBS practices. Therefore, a clear citywide vision and goal of WSC should be set out for climate agency. Especially, I can mention here that the Green Ankara city plan, what they are doing right now, the water sensitive city by NBS should be incorporated in there. So NBS are implemented in diverse ways, but a guideline also is needed to implement it. Community participation and acceptance seem to be a key factor in ensuring success. Awareness of and the advantages of water security sensitive city should be communicated to the public in terms of knowledge and design. So especially the European funded projects and some others, it's very much more, we found very effective. So international policy practices should follow up, build capacity of the local consultants and contractors, demonstrate the projects to the municipalities that will help stakeholders and developers to see and experience water sensitive city benefits. Thank you all.
Thank you, Dr. Essen. So may I call second speaker, Ms. Araya Yotmangkol. She is from Department of Water Resources, Thailand. So you also have 10 minutes. Yeah, please.
Okay, thank you. Good morning, ladies and gentlemen. I am Araya Yotmongkol, who work at the Department of Water Resources, Thailand. I think it's not too late to say that welcome everyone to Thailand, Smiley Land. Please smile, always smile when you stay in Thailand. Today, I will present you about the implementation climate change adaptation for monitoring and evaluation EBA intervention at Hoi Chuk, Thailand. This study, my colleague, Mrs. Radha, she presented yesterday about the environment sector, but now today, I will focus on social and a little bit economic sector. Okay, following the Global Climate Risk Index 2021, Thailand ranked 9 among countries that were most affected by extreme weather. Moreover, El Niño, La Niña phenomenon and climate change scenario accumulate the water disaster. And moreover, flood and droughts always occur in the various areas in Thailand. And it affects in every part and every sector of Thailand, especially agricultural sector. Today, if you see the map, you can see Hoi Chuk and Nong Yai reservoir. This is the study area for me. And Hoi Chuk is the watershed of Nong Yai reservoir. Nong Yai reservoir is an important water resources for domestic use and the agricultural sector of people in Khon Kaen province. But in the last day, Nong Yai reservoir has a special and important issue that related with sedimentation. It decreased water storage volume and increased the cost of drinking sediment out of the reservoir. If you see the graph, you can see the trend of rainfall and runoff of Hoi Chuk area. You can see the average rainfall decrease and the average runoff also decline continuous. So it means like it's like the risk of this area. And in 2019, the Department of Water Resources, this is the organization which I work. This organization established the EBA intervention. They compose of 3 sediment trap weirs and riparian zone development. This organization try to use climate change adaptation intervention to try to adapt with climate change risk, especially in the risk area like Nong Yai and like Hoi Chuk. The objective of this project is to implement the tools for monitoring and evaluating this EBA intervention. The study area that I mentioned before, I focus on a 2-kilometer radius of Hoi Chuk area. This one it cover 2 villages, named Hoi Chuk village and Hoi Sang village. For collecting data, I collect both of qualitative data and quantitative data. I start with qualitative data by using the tool with focus group discussion. And I think it's not enough. I want more detail in deeply. So I use a questionnaire for collecting the quantitative data. I ask them like each one by one. So I think we can get the point in deeply with the questionnaire. The population size of this with agricultural part and the age are in the range of 45 to 75 years old. And for evaluating this EBA intervention, I separate in 3 dimensions. They compose of awareness, occupation adaptation, and conservation participation. Let's start with the first part, which is the awareness. If you see the graph, you can see that people around 85% understand and they agree. They understand that climate change related with economic, social, and environment, as well as the people around 82%. They know and they understand as well. Like if they use more natural resources, the more climate change risk increase. If you see the graph, in the questionnaire, I ask the people to give the score to give the score that they understand about the advantage of the weirs that the Department of Water Resources or the government built. They understand about the benefit that they will get from the weir in give the score, and the result that most of people give highest score for accessing food, supporting water supply in the dry season, enhancing biodiversity, and increasing quality of life. But on the other hand, you can see about the promoting ecosystem. This is like just only around 70% of people that give highest score for this point. And in the second part, that's about occupation adaptation. I ask them with a focus group discussion about do you have any adaptation with climate change in the area? They focus on rice planting. They try to shift or postpone the sowing rice by normally they grow the rice from June, but they shift to grow from May because of the change of the rainfall in the area. And moreover, some people told me that they try to change to grow the plants from the rice. They plant the rice just for their food, but for selling, they try to grow other plants which use less water instead, such as cassava and sugar cane. Moreover, people who don't have their own land, they try to hire to harvest from the other land for their income. And in the last part of the result, it is the conservation participation. I used the questionnaire to ask them do you want to help the government for conservation, the sediment trap weir or not, or in which part that you want? Around 93% they're willing to devote time, dedicate labor and support the agriculture, but the people around 7% they disagree. They think that it's not their duty, it's the duty of government. So the conclusion of my presentation, the tools of focus group discussion and questionnaire can monitor and evaluate the EBA intervention at Hoi Shuk area. Target group, target people around, target people who live in a 2-kilometer radius of Hoi Shuk. They are aware that climate change impact and they understand the advantage of EBA intervention construction. Moreover, people in this area, they're ready to adapt their behavior because of climate change scenarios in terms of occupation adaptation. I forgot one point. Some people, they said that they try to find another water resources, such as groundwater, instead of water on the land, in case of drought. And people, they adjust their agricultural planting, which use less water, such as sugarcane and cassava instead of rice, in terms of selling. And people over 93%, they're ready to support government for conservation these sediment trap weirs. And recommendation of this study, I think the data on occupation adaptation part should be collected every year because the data from various years can be compared and analyzed, provide a trend of climate change adaptation of each area. And the monitoring and evaluation of conservation participation should focus on willingness to pay in both monetary and money form because it can calculate for providing the budgets for conservation, improvement and development for future projects as well. And these are reference. And the last thing, I would like to acknowledge my organization, which is the Department of Water Resources, that give me, support me and give me some occasion to be part in this conference. And I would like to thank you with my advisor, my colleague, and would like to thank the WSCC organizer which support me and give me some occasion to present here. And the last one, would like to thank you with everyone to be part in my presentation today. Thank you.
Yeah, thank you very much, Ms. Sarah. That's exactly on time. So I'm sure you have, plenty of questions. So as I, mentioned earlier, please keep them at the end. So we will have a Q&A session, so you can have questions. So next, I would like to invite Mr. Nishal Devkota. He's from Nature Conservation and Research Hub from Nepal. So Nishal, you have also 10 minutes. Yeah, sure. Thank you.
Thank you. A tale of necessities and constraints. It's a tale of an initiative I wanted to take as an aquatic ecologist with my organization, Nature Conservation for Research Hub, and it's an initiative I wanted to take before my current job at the Ramsar Convention. But it's a tale of that initiative I took along with some like-minded young conservationists in Nepal, and we gave it the name Wetlands for Nepal. We took this initiative for the necessity to take immediate actions on wetland conservation in Nepal, especially in urban areas where the rapid urbanization is ensuing a lot of problems for wetland conservation. And those problems are aggravating with climate change effects. So I believe that one of the solutions might lie in community-led wetland management, even in the urban settings. And that's because Nepal has had good examples of community-led resource management systems. For example, the community-managed forests. So why not replicate that in wetlands? And the second thing that might be important in that would be to integrate nature-based solution, because one, nature-based solutions are proven mitigation, resilience, and adaptation measures. And second, they sort of complement the participatory community-based resource management. Now the tale begins in this lake called Nagdaha, which is a semi-urban lake 20 kilometers south of Kathmandu, the capital city of Nepal. And it is quite popular for the indigenous white lotuses and some wetland birds, resident migratory, and the popular Nag Mandiri temple, which roughly translates to serpent god temple. And this is also from where the name of the lakes comes from. And from our initial observation, one of the main problems at Nagdaha that we found was maybe related to sedimentation and nutrient pollution, born out of catchment runoff from the southwest side of the lake, as you can see on the map. And we hypothesized that the subcatchment A, which is predominantly an agricultural land, would be responsible for nutrient pollution, while subcatchment B, which has an extensive housing project, would be the primary cause of sedimentation. Then we conducted the initiative in four phases. The first two phases were dedicated to encourage community participation and to identify the challenges and boundary conditions of the initiative. So the boundary conditions are the challenges I'm referring to that can cause semi-permanent to permanent limitations to the initiative. And so we conducted 3 group meetings with different group of stakeholders, and also conducted an workshop. And based on that, we identified those challenges and also provided a platform for the community to take part in the initiative. So the main challenge we identified was to integrate community and government working mechanisms. And for that, we needed a platform for inclusive decision making. A second, which is no-brainer, every project sort of requires money. So seed funding was vital. And third, we needed to engage large corporations in the restoration. So for example, the housing company, perhaps. And such engagements are sort of missing from these sort of initiatives, especially in the urban settings. And the financial limitations we found that maybe we realized later on would provide more permanent limitations to our project, and similarly with political interferences, because for example in Nepal, the local and national elections sort of hindered our project for like 5 months or so. In the third phase, we began to characterize the problem that we firstly associated with nutrient and sedimentation problem. So we ran a nutrient analysis on mainly nitrogen and phosphorus-based compounds, along with some basic water quality parameters such as oxygen and turbidity. And we did it pre-monsoon sampling and post-monsoon monsoon sampling. And then for sediment analysis, we took sediments from the inlet and also the lake and subcatchment A. So we did a composite sampling, because composite sampling provided us a means to do the research scientifically, but at the same time preserve some money, which was highly important. And third, we collected average daily rainfall data in monsoon period using the local people as citizen scientists. And we also utilized locally available tools such as these homemade rain gauge, which design has been proven to have only like minus 2.9% error compared to the standard gauge used by the government of Nepal. So the main results was that the lake was highly eutrophic. Obviously, there was the total nitrogen to total phosphorus ratio was high. But the catchment water that was coming from our problem area that we identified before, it had low nitrate and phosphorus compounds. So there was negligible nutrient loading coming from that catchment. But the sedimentations, the total suspended solids and turbidity was quite high in that water. So, and we, from the sediment samples, we also found that there was high sand deposits in the lake, so 48%, but there was low sand deposits in the subcatchment A. So this suggests that maybe the main problem is sedimentation, but born out of catchment B, not catchment A. So we had to focus our solution in that regards. So this was the final phase where we implement the solution based on the problem that we identified before. And the solution that we thought of was to actually create a retention pond so we could retain all the sediments coming from the catchment. So if you follow the arrow, pretend that it's raining. So when the rainfall comes and the runoff water follows the arrows, then we would divert it to the buffer region, the pink shaded area. So that what that will do is that will lower the velocity of the runoff, and the bigger sediments will be allowed to settle down, and this will also not allow the main retention pond to overflow. And then the water will flow into the main retention pond afterwards. So in the main retention pond, with the help of the average daily rainfall and the catch surface area that we calculated before, we found out that we needed at least 360 meters cubes volume of the pond. And our design actually incorporates 480, so we are good on that aspect. And our pond will be divided into two aspects. The deeper region will allow the sediments to collect and settle down, while the shallow region will have reed beds so that they can retain any nutrients that have been collected on the deeper area. So finally, there are like 5 elements that we were able to discover that are essential for community-led Western restoration in urban settings in Nepal, especially. First, every nature-based solution should be research based. So you have to characterize the problem beforehand with scientifically available tool as far as possible. Second, you have to use indigenous knowledges and locally available tools because they will have some positive aspect that you might not have found anywhere else. And also they are quite cheap, you know. And third is you need to provide a platform where all the community groups can come together and be involved in the decision making, because once you finish the initiative, you leave, but they will be the ones responsible to maintain whatever the solutions that you have implemented. And fourth is like you have to identify all the challenges and the boundary conditions and do your initiative within that regards. Fifth, nature-based solutions can generate fund, but fundings are usually limited. So you can do a circular economy model. For example, we are planning to utilize the lake resources like fishes and reed bays and everything that we can find within the lake sustainably and provide and sort of use that to generate income. And that income will go back into lake management. So that's something that can be do in the nature-based solutions. So unfortunately, our project is not complete because of the political hindrances I mentioned earlier. So I cannot share with you how much impact it have had. But if you want to stay tuned with the project, then you can scan this code or follow our website. And if you want to know more about me, you can just go to ramzak.org. There's a big profile on me. And finally, I have tried to sort of refrain to use that project word, but I have failed a little bit. But because projects have deadline, but initiatives, they can turn into a movement. And I hope wetland conservation will turn into a movement in Nepal. So thank you. Thank you very much.
Yeah. Thank you. Yeah, thank you very much, Nissal. I hope your project will continue and we will have some, the outcomes in the next conference also. Okay, so I would like to call upon Mohammad Abu Hasim. He's from Zagazig University in Egypt. Yeah, you also have about 10 minutes. Yeah, thank you.
Okay. Ladies and gentlemen, good morning. I have the honor to be here today to display some results of different projects, mainly depend on natural-based solutions for wastewater treatment and climate change at arid regions. Egypt, there are many small villages. It's going. Okay, it's good. Okay. Okay. In Egypt, there are many small villages and hamlets whose population is less than 1,000 people suffering from the lack of sanitation. The main problem is that they are far away from the urban area, and the situation of the wastewater treatment is extremely difficult. And the current policy depends on the central facilities for the wastewater treatment and the transporting wastewater through raising mains and pumping situation. For the water resource in Egypt, we mainly depend on the Nile River with approximately 58 billion cubic meter and approximately 1.5 billion cubic meter from the rainfall. This water, approximately 88 billion cubic meter, 85% of this amount for the agriculture sector and 60% for the drinking sector and approximately 10% for the industry sector. Egypt is still facing a major challenge of how to increase the rate of growth in agriculture production to generate and meet the future of food requirements to cope with a very high annual rate of increasing in population. You can't imagine that the population was approximately 20 million in 1952 and was 100 million in 2018 and expected to be 150 million in 2030. So I would like to speak about two approaches. We speak about wastewater treatment and we speak about climate change mitigation. The first issue that the small village, as I mentioned before, that lack all sanitation. We speak about small village that's so far from the urban area. This small village lack of any kind of sanitation service. They usually use the cheapest and easiest way for them to wastewater disposal. They use a septic tank under and near to their houses to throw the wastewater in it. And these tanks could cause two main problems. The first problem is the leakage of the contaminated water to the underground reservoir and for sure contaminate the agriculture drains. The second issue, all the time, should we blame the industry as they are the main source for the carbon dioxide emission? Or is there another kind of carbon dioxide emission that released from the agriculture management? This is the second issue. For this, me and my team, my students, my PhD and my master's students, we start as a novel fingerprint in the Nile Delta. We identify the impact of the land use changes on the soil surface organic carbon pool at the Mediterranean region. We identify a catchment area in Egypt to identify the impact of the land use change, soil types, and the site variables on soil organic carbon pool in the north of Nile Delta, and assess the impact of the sequestrated soil organic carbon pool decreases on the emitted carbon dioxide and enhance the concentration of the green gas in the atmosphere. We found actually interesting phenomena. As a result of the urbanization on the cultivated land in the Nile Delta, what happened? Losing the arable land to urbanization result in decrease of 285 gigagram carbon of the soil organic carbon. Actually, it is amazing results. This phenomena, we noticed it in Egypt during the previous 10 years. They increased the urbanization on agriculture land. So the agriculture land lost its potentiality to sequestrate the carbon into the soil, which result in losing approximately of 285 carbon should be sequestrated into the soil. That result of emitted of 1,000 gigagram carbon dioxide to the atmosphere. This is the first alarm. The second one, me and my colleagues from Germany, Technische University Berlin, Morocco, Tunisia, Egypt, we initiated innovative constructed wetland for the Mediterranean region through the project that funded by European Union through the program of ERA-NET program. This project mainly depend on constructed wetland. I noticed my previous colleagues who spoke about wetland. Here we make for the rural area or the small village so far from the urban area, constructed wetland that will help the small village and the farmers instead of disposal their wastewater into the drains. No, we can go through this constructed wetland and get a good water with good quality could be used for irrigation for another purpose. So in this case, here, this is a constructed wetland. Why we choose this? Because it is easy for operation and maintenance, relatively low construction and operation costs, minimum energy input. This is the aim of our construction wetland for the village. And here is the technical cross-section of the vertical filter unit. We can notice here, this is the distribution of the system of the pipes as a soil surface, and this is a distribution for our experiment of the pipes at the bottom, at the layer. And here is the gravel, which we put it at the bottom of the layer. And here also the sand. Here our design depends on the German code for the constructed wetland, which we modify according to each local area. Tunisian colleague modify it according to their local materials, and Egypt and Morocco, but depend on the same technique here for the German code. For our work, we work directly in a wastewater treatment plant. We go to here in Zagazig for Al-Qanayat city. Here is a wastewater treatment plant, so close from university. We initiated our project to work directly from the wastewater after the preliminary treatment. We use sediment tank to sediment all the heavy materials at the beginning before pass the wastewater to our units. This is the wastewater characteristics. You can notice the COD and the BOD and different parameters. Here is our units. Here we should note something. Our colleagues spoke about, okay, how can we motivate the stakeholders? This is our discussion during the previous 2 days with my colleagues. How we can motivate the stakeholders to use this technique of wetland. Should we promise them or advise them use just only trees as a green area, or we can advise using economical plants which can be used as materials for construction, like this, MDF or furniture. So we start with different review of literature, and we select economically plant with high efficient in wastewater removal. We select Paulownia, which used for furniture in Italy. We used Saisaban, which used for MDF manufacture. Bamboo, for sure you know bamboo, and Phragmites australis and Ricinus, to identify its potentiality for two different issues: wastewater treatment removal and carbon sequestration into the soil and reduce the carbon dioxide emission. Here we built our control system to link it to mobile and computer. All the team could follow the system. If there is any mistakes in any times, they can get into to fix it. This is our control system. The most important issue here, how to select the media. We depend on our local media, and we spend approximately 6 months in Faculty of Engineering in the lab of soil mechanics, actually to investigate the right media. What's this meaning of right media? We try to make all the media to avoid any clogging in the future. What about after 6 months, 1 year, 5 years? Maybe it will be clogging. No. We select our media. We make several tests to identify the right media and the right construction to guarantee that after 1 year, 10 years, there is no clogging in the future for our system. We make several investigations. Hi. Okay. Here, to identify the right percentage from the gravel and the sand, to identify, okay, this is our media selection. Then we start cultivation process in different units in the wastewater treatment plant. This is a control unit without any kind of plants.
Yeah,
here is Paulownia, 2 minutes.
Yeah, okay.
Paulownia, and here is Ricinus. Here is Saisaban. You can notice the growth after 2 months. Actually amazing. Here is bamboo. Here is Phragmites australis. And this is the results. This is the COD results and the removal of results. So we notice that the bamboo and the Saisaban was more efficient in removal of COD. Also the same for bamboo, Saisaban and the Paulownia is more efficient in BOD removal. And also we analyze the plants and to see it's efficient for the removal of different heavy metals. We tested cobalt, nickel, cadmium for the heavy metals, and also the same plants give us Paulownia, Saisaban, and bamboo, the more efficient for removal heavy metals from the wastewater. And finally, we investigate the soil organic carbon pool to identify the carbon sequestration into the soil. We found that the Paulownia and Saisaban sequestrate approximately 35% of soil organic carbon into the soil. That means reduce the emitted carbon dioxide to the surrounding atmosphere. And here our design for the small village, when we already moved to another project now to make it for a small village. This is the design for the small village. And finally, my colleague, my message here for all of you, please select the economy and attractive plant type that motivate the local farmers and the stakeholders and the policymaker to grow and invest it. Thank you for your attention.
Yeah, thank you, Mohammad Abu Hassim. Sorry to interrupt you in the middle. Yeah, so, okay, yeah, I'm sure you have plenty of questions, right? So let's skip at the end and then we'll have this Q&A session. So I would like to invite Nikita Madan from National Institute of Urban Affairs in India. So she will be presenting about urban water body diagnostic tool. Yeah. So you have also 10 minutes, Nikita.
Thank you so much. Sawadika. Good morning. Hello. How are you all? I'm hoping that I'm seeing some yawning faces, but I'm hoping my presentation can wake you up. Okay, so since the past 2 days, we've been hearing a lot about making the theoretical aspects that we've been studying and getting them into action. So that's something that we are attempting through this tool. I'm happy to present my tool on urban water body diagnosis. It's an instrument for assessment of water bodies within any city. I'd like to acknowledge my co-authors, Dr. Victor Shinde, who's here in this session, and also Vishakha Jha. Let's build the context here. These are some news glimpses from 2019 and 20. 70% of the water bodies vanished in over 3 decades in Bihar. Lucknow loses nearly 50% of its water bodies to encroachment by builders. Though these are glimpses of news clippings from India, we see such news across the world. We are losing out on our water bodies. Hence, we started looking at the various indicators, frameworks that are existing nationally and internationally that help in assessment of water bodies. Even if we go towards rejuvenation, we need to identify the status of the water bodies. You see a lot of frameworks, and there are many more researches, many more practical examples that have been taken up by experts all across the globe. But what we saw there is, while many of them are focusing on biological factors, chemical factors, biotic components, there was a clear need for simple enough tools that can be used by city officials, and also a need for a holistic thinking which incorporates all parameters. Hence, we went about with the National Mission for Clean Ganga and UNESCO New Delhi, we prepared this urban water body diagnostic tool. The tool aims to support as a decision support system for cities to manage the water bodies within their jurisdiction. It helps to identify and prioritize action for rejuvenation of water bodies. So if you have 100 water bodies in a city, which water bodies require immediate action? This tool will help you do that. Quickly going through the design philosophy of the tool, it's a holistic assessment. It looks at various parameters all across the expand of study. A rapid assessment, you do not need to wait for results, wait for anyone or any information. It's quickly accessible. An action-oriented assessment, based on the results of this tool, you can actually take it to an on-ground site intervention level. All the indicators in this tool are based on the SMART criteria. Some key considerations while developing this tool. This is applicable for urban water bodies at the moment, but it can be contextualized to different kinds of wetlands and other specific water bodies. Since we were looking at Indian scenario, we were looking at various examples from policies and guidelines across India, and they kind of mandate to protect and secure the water bodies of 1 acre and above. So for the purpose of this tool, we took this as a deciding criteria. And also looking at various examples of guidelines and frameworks and master plans across Indian cities. For the purpose of this tool, we took the water bodies buffer as 9 meter, minimum 9 meter for all water bodies that are less than 10 hectare, and 30 meters for all water bodies that are greater than 10 hectare. Coming to the dimensions and indicators, and this is primarily what the way we assess through this tool. There are 4 dimensions under this tool. The physical dimension, basically what we see visually when we go to a water body site, and the smell of it. Under that we have 4 indicators: visible surface algal bloom and floating macrophytes, odor, solid waste within the water body, and solid waste within the water body buffer area. The water quality dimension, which is basically to identify the chemical and biological features of the water body, which has 2 indicators, dissolved oxygen and pH. Water quantity dimension, which is basically to understand the change in the area, in the water quantum of water. So it has 1 indicator, change in surface area of the water body. And the management dimension, which has 3 indicators: extent of build-up in the buffer area, vegetation in the buffer area, and management protocols. I'll quickly run through all of these indicators one by one. Visible surface algal bloom, it's basically calculated by understanding the percentage of the water body surface area that is covered with surface algal bloom. If the water body surface area is completely covered with surface algal bloom or floating macrophytes, it's given a score of 0, which is poor scoring. And if there's no floating macrophyte or surface algal bloom coverage, you're given a score of 5, which is good. Odor, if there is a presence or absence of odor within the water. So yes, if there is odor, it's given a score of 0. Solid waste within the water body surface area. So we see the floating solid waste that's there in the water body surface area, and the ranges are there, you can see them. Solid waste within the buffer area, if there is any solid waste present within the buffer area. If there is, you give it a score of 0. If there's not, you give it a score of 5. Then going to the quality parameters, the DO meter, the dissolved oxygen level. So you simply take a DO meter, you go to the site, you test the DO level, and the value in mg per liter is used to assign the scores, and it's as per Indian standards that we've given the ranges. pH meter, again, a simply quickly doable tool. You just need to take a pH meter to the site. You do not need any technical ability. You just take a water sample, test the pH using a pH meter. 6.5 to 8.5 is a desirable pH as per Indian standards, so you can give it a score of 5, and the rest of the ranges are there. Change in water surface area. So what you need to see is how the water body surface area has changed based on as a regard of the baseline surface area. So the baseline surface area is the surface area of the water body that is as per the records that was supposed to be there. If we do not have the record, we see how it has changed as a measure of the average of the previous 5 years. So how it has changed. If it has increased or it's the same, it gets a score of 5, and so on and so forth. Built up within the buffer area. Again, we see if there is any built up within the buffer area. So the percentage of the buffer area that is covered with built up, and you see the score ranges. Vegetation within the buffer area. So you see what kind of vegetation, native vegetation, is required for the water body as per the city context, and what percentage of the area is covered with that vegetation is something that the score is based on. And the last one is the monitoring mechanism. So even after having all of this, if you do not have sufficient monitoring mechanisms within a city, you cannot manage the water body. So if the water body has a dedicated land use within the development plan, if there is an assigned buffer, if a monitoring agency is assigned, so all these you evaluate through this criteria. So the 10 indicators, once you get the score of 10 indicators, you multiply it by the indicator weight to get the indicator value. And to get the indicator weights that I've mentioned here in this column, we conducted an AHP exercise, an analytical hierarchy process, wherein we invited a set of experts working on Indian water bodies, and they assigned the relative importance of each indicator. The sum of each indicator value under each dimension gives the dimension value, and then you have the UWD value. So each water body gets a UWD score. The score is within the range of 0 to 5. A lower value meaning the water body quality is poor, hence it is extremely neglected and it requires immediate action. And 5 meaning it's in an ideal condition and it does not require immediate action. So this tool is definitely helping cities to identify and prioritize action as to which water bodies they immediately want to work on. We did a pilot testing of this tool in the city of Visakhapatnam in India. Some glimpses from there wherein we actually did the site testing. As a follow-up, a way forward, now that we've developed this tool, what we are doing are two things. One, we are developing an online web-based browser mechanism wherein cities can actually enter the data and just get the results. And they can also form an online database. So this will be available online soon. What we are also doing is we are talking to cities, meeting more cities to apply this tool within India at the moment. And the manual that you see here, I have a copy at the back there for your reference as well. You can have a look, you can scan the code, it's available online. Though, in the end, I would like to mention here that though the ranges have been contextualized in the Indian scenario, for the Indian scenario, you can contextualize the ranges and make this tool applicable for any city across the world. So we are hoping that more and more cities can start adopting this and have a self-evaluation of the water bodies within the cities. Thank you.
Okay, thank you, Nikita, for introducing the excellent tool. So now we have about 10 minutes for a question and answer session. So we have 5 presentations. If you have any questions, you can just raise your hand and you can direct your questions to the speakers. Okay, yeah, I can see Dheerajji, please.
Thank you. My question is to Nishil. First of all, thank you for including Nagda in your presentation. That is the location where I live, and I also have one project to clean the water. So it's very nice coincidence that we are working at the same site. But my question is related with the rain gauge that you have used as a citizen science. You mentioned that it's undercatching only by 0.2% or 2% only. So that's very nominal, I think, right? So how did you do that calculation with the government standard? And the second thing is, I really appreciate that your approach is to control sedimentation from the source, not only to the lake. So what are the other measures that you are planning to do, or because your study is still ongoing, to look after other impurities that is coming from the settlement or from the road, or because this is a good example for not only the locality, for whole region, that is very much replicability to the other regions. So thank you once again for your presentation. Yeah.
Thank you so much for the question, and I think we should get together later on and have a talk. It's nice to meet people from the same region, And with regards to the rain gauge question, that study took around 2 years. So we built the rain gauges, we had a design, and then we considered a lot of factors, because it was a concrete made rain gauge with a soda bottle, right? So we have to consider condensation, evaporation, and then also compare it with other standard gauges like tipping buckets and stuff. So we did that for 2 years, and then the paper is published in Frontiers Journal under Davids et al. You can find it. So based on that, our error was just minus 2.9%. So you can use that rain gauge, and the design is commonly available in web. So that was that. And the other question regards to what we are planning to do next. Well, after this is finished, we are planning to sort of give the whole initiative to the local youth club there. So they will be the one responsible to sort of maintain the pond later on. That's the thing. Then we are working with the local government to come up with a lake management plan. So once the management plan is done, then activities can go accordingly. And as you said, that there are a lot of activities and projects happening in that area. So this is sort of will put this into a same umbrella. That's the hope. Thank you.
Okay, thank you. So I see a couple of hands, so I will pass microphone here, Dr.
Thank you for your actually excellent presentations. All of the 5 presenters actually present very well. My first question to Dr. Manul Hassan, could you please tell us about some aspect of nature-based solution that you showed us in Ankara? How can we actually replicate this in some other developing countries, from, for example, Bangladesh?
Yes. Yeah, I already mentioned that some tools can be used as nature-based solutions, like a biological pond can be implemented in parks in Dhaka or other cities also. So biological pond is very easy, and rainwater harvesting also it's common, you know, every country they can do. And from my perspective, especially the big parks, especially, they can implement biological
But one
pond.
challenge is that actually biological ponds may create some eutrophication problem.
Yes.
Because of high temperature in tropical countries like Bangladesh.
Yes, especially they need regular control, monitoring as well. For example, in Turkey, there is all the municipalities, they have environmental protection and control department.
Okay.
So in Bangladesh, so they need also this type of control department. They can manage regularly. Yeah.
Okay, thank you so much. And my next question to Professor Abu Hashem, so which plants actually, according to your observation, was most successful in that actual nature-based solution that you showed us in Egypt?
Yes, actually it is interesting. As the last slide I mentioned that, please, if you'd like to speak with the stakeholders and the policymaker, try to motivate them use the most economically planned. At the same time, it should be have efficient for the wastewater treatment and for the carbon sequestration. We tested several plants and we identify Paulonia and Saisaban. Both of them used for the furniture and the MDF production. So we can promise and we can motivate these 2 kinds of plants could be used all over the world, not only in Egypt.
In Egypt, actually, you're actually like desert and very high temperature, bamboo tree could be a successful one?
Yes, yes, we tested that.
I wondered actually.
And also currently we work in mangrove at the Red Sea coastal, also for the same reason. Not for the wastewater actually, but for the carbon sequestration and for the soil water erosion at the coastal area. We focus also in the same time in another project. Okay.
And last question actually,
yes,
basically to Nikita Madan. Actually, you showed us a very excellent tool. Actually, could you please tell us how could actually we replicate this one in other countries as well? Because it's a budget and time, because to assess all of these tools particularly.
So I'll share some example from our first, the time required and the resources required from the experience in Visakhapatnam. So it's a resource, it does not require much of a resource. The tools, the equipments that are required are not very costly. For every water body, it took us like 30 minutes of an evaluation time and going back and just entering it. So you can easily do it. What you need to look at when contextualizing to other countries are the ranges that are referred. Just you
need at least some trained manpower who could actually assess and who could
yes,
see and visualize What is
Yes.
the real problem? Okay.
Yes, so the trained manpower again, like the tool has been made so simple just to ensure that anyone with a basic technical ability working in any city authority can actually go and implement it. Once you just give them a quick training, anyone can do it, and that's what we realized in the city of Visakhapatnam as well. There was a set of, you build a set of 8 to 10 people team, and they can just with a simple training do it. And the ranges that were there were very specific to Indian context. Just for example, the vegetation cover, you have a different vegetative canopy density in arid regions vis-a-vis some Indian cities and all. So once you modify the ranges as per your city context, you can actually apply the tool to your cities as well.
So after diagnosis, actually, what will be the recommendation? How will the immediate action?
Yeah, so every water body gets a score based on different dimensions. One, you will understand which water body requires immediate action. You can take them up for rejuvenation. Two, you can identify under which dimension they are scoring low. So what kind of action is required is also can also be.
It requires another team and another actually.
Yes, yes, yes.
Hello. Thank you for all of very interesting presentation. So I have a question addressed to Ms. Nikita Madan. Thank you for your presentation. I say the methods you propose is simple and applicable to many people. But I just wonder how you come up with the weighting factor. And do we need to frequently double check the set value, and then how you monitor and assess the accuracy of the index? Thank you.
Thank you so much for your question. So the weighting criteria, we used a process called analytical hierarchy process, AHP. We invited a set of experts working in this sector. We gave them a questionnaire survey wherein we asked them to evaluate one set of indicators against the other in terms of its relative importance. It's a standard scientific process that is used by different weighing scales, and then based on that we identify the weighting factor. Your second question was about the accuracy of this and the frequency of this. So once you identify this and identify the values for each water body, this is the first step. You go back to the site, you identify the rejuvenation mechanisms. Once you have those rejuvenation mechanisms in place, the quality of the water body would change. So your score would again change. So what we are saying here is you can do this regularly. You can apply this regularly within cities. Like every year, you're kind of diagnosing the status of all the water bodies in your city, and based on that, you are identifying the rejuvenation mechanisms. Does that answer your question?
Thank you for your answer. But I mean, whether we need to combine with other action, using more scientific methodology in parallel, and sometimes double check with this simple methods.
Okay, yeah, I get it. So this is a rapid assessment tool. Once you prioritize the water bodies that require immediate action, because there are a lot of other parameters which are scientific in nature that needs to be calculated. So you do a detailed assessment for those specific water bodies. How this tool helps is you cannot actually do a detailed assessment of many water bodies in your city, but you identify a set of top priority water bodies, do that detailed assessment within those water bodies, and take them up for action.
Okay, thank you. I think we have coffee break also. You can, discuss during the coffee break. One more question, yeah, please.
Thank you, everyone. My question is to Nikita. So what happens after the assessment, right? Because for most urban authorities, it might, unfortunately, it's not the quality or the situation of the water body that is not enough for them, because redevelopment, reclaiming, I don't like that word at all, but that's very popular amongst them. So do you have any good experiences to share, maybe from Vishakhapatnam when you took it to the authorities, or if you did, or any other projects? What has been the experience like of taking such assessments to the authorities?
So what happens after this diagnosis, again just mentioning to the aim of this tool helps to prioritize which water body require immediate action. Once you have a score for each water body, you know which water body requires action, under which indicator they require action. Are they falling short on the physical parameters or the quality parameters? That is the action you need to propose for the water bodies. Then you identify very specific projects or interventions based on the scoring of each water body. That is very site specific. Each city can take it up as per the rejuvenation needs. I would be happy to share experiences of our prior studies with Vishakhapatnam. Maybe we can take that up over lunch separately as well.
Yeah, thank you. I think Miss Araya didn't have chance to have some questions, so probably shall I? Okay. So my colleague, he has also a question, but yeah, it's a bit, yeah, please.
I'm Narumon Bunyawong from the Department of Industrial Works. My question for Ms. Arya. Could you please tell me why you choose study in the Hoi Shek area?
Okay, thank you for your question. Because this area is a very interesting area, and it is the risk area. Because before I studied this, the GIZ or German Thai Cooperation Organization used to use this place to be the place for the EcoSWOT project, or the project that related about the management of the risk area, and try to use ecosystem-based adaptation in the watershed. And this area is one of the place that GIZ organization try to use the EBA intervention in this area. And moreover, my organization built the EBA construction in this area as well. And my project is related about monitoring and evaluating those EBA intervention. So that's why I use this area.
Yeah, thank you. I think we are running out of time, but my colleague wants to ask one question. Yeah, the last question, yeah.
Yes, I think it's a follow-up question with also the audience here, and also to Ms. Ayara. So usually when we talk about EBA or NBS, we envision, also myself, think about something quite green, vegetables, vegetation, animals, biodiversity. But in the case that she presented, it was actually aware. So I'm curious to see like how the starting point, why you choose the EBA in your case was aware. To evaluate as a case study for an ecosystem-based adaptation. Thank you.
Okay, thank you. Because my organization try to use the climate change adaptation with the water construction, and they choose to use the sediment trap weirs to in this area for reducing the sediment which in the Nong Yai reservoir. And when my organization built this construction in this area, and I would like to know about awareness of the people around this weir, that they ready, or they about their awareness that they're ready for conserving this construction or not. But the result, if the result is not, it's the duty of local government to take more education for them. So I think it can we can go on about this project. Thank you.
Yeah, thank you very much. I think we have no time for other questions. So I would like to conclude with a few remarks. I think this session was wonderful, because one of the objectives of this session is to explore what are the nature-based solutions and how we can implement it to enhance the water security. And I think we have seen, in many diverse geographical region, there is a successful implementation of nature-based solutions. And of course, they also provide benefit. You can, see some of the benefits presented by the presenters. For example, sediment deposition and removal, wastewater treatment, and also carbon dioxide emission reduction, right? So they also provide the benefits. At the same time, I have also two observations. One is probably all of the presentation. I'm sure you will do further analysis. What are the cost-benefit analysis of these kind of nature-based solutions? Probably that is very much needed. And the other thing is, what are the requirements of the policy guidelines to implement these kind of nature-based solutions, and also the scaling up this kind of nature-based solutions. So session was wonderful, and I'd like to thank all the 5 speakers, and let's give them big round of applause. And I conclude this session. Thank you very much. And also I thank Dr. Locke for reporting this session. Thank you.